A very good afternoon to all, dear students and faculty members. So today we have with us Mr. Ankan Das, sir, who is the senior faculty in animation. So he is going to discuss about creating isometric worlds, and he is going to share his experience with you guys. So I welcome you, sir, and over to you, sir. You can start the session. Thank
Thank
you.
you. Uh, a very warm welcome into our webinar today. This webinar is going to be focusing on a particular subject of how to draw and create the isometric world around you. Now, before we start with the webinar, I would like to have some of you who can communicate continuously with me. It means I would be asking a few questions in terms of kind of interaction between the student and the speaker. There should be some people who answer those questions. I do not mind whether it is right or wrong. And obviously, I knew that there are some people who feel like, a little inconfident about answering questions. If we just leave them, there should be at least a few people who communicate about the questions that I would ask during this progression of the webinar itself. So I started my career as a very basic designer with some website designing and all those sort of things. Later on, I moved into the animation, and I am basically a 2D artist. So a 2D artist is, a kind of people, who are concerned to the very basic design forms. Okay, they require minimum tools. That's how they have been trained. So in my cases, the basic tools are like a pencil or Wacom tablets, pen or whatever you call it, an induction pen nowadays, that constant technologies. So these are the basic things that I often use while I'm trying to create anything. Okay. So why am I bringing this thing into this webinar? That question arises. See, the particular thing that we are going to discuss today in this webinar is going to be something called the isometric drawings. Okay. If you look at them in a very casual eyes, with a very casual eyes, definitely, you will find like these look pretty much like a 3D world around you. Okay, it looks like a 3D software has created the whole world around you, and that is what exactly we call the isometric drawing. Okay, now the thing is, when you focus at this particular area, the question is, these are actually drawings, not the 3D softwares which are responsible for these particular drawings. Okay, instead these are very the mostly used software for this kind of the creation of this kind of drawing is actually a 2D based software called Illustrator. Okay, now if we start drawing, now more or less we all know a little bit of drawing, right? If we just start with a drawing, what it is we see in case of a drawing. What are the differences between the drawing that an ordinary guy does and an artist who is doing an isometric drawing, does in his drawing? The same kind of thing. For the same kind of thing. Can anybody tell me? Is it the color? Is it the lines? Is it the background? What is it?
Normal people start drawing with just nose, eyes, and they start directly with the eyes, head, and like that. But the artist draw using shapes and other kind of things.
Okay, so that's a try from one of the fellow. I know which university you're from. Okay, anyways, I could not follow the last.
Ajinkya Dev Patel.
Yeah, okay. Anyways, so so let me share a screen and I will try to draw something because I'm from the drawing background. So I'll try to draw something first. Okay, I hope you guys can see my screen now.
Yes, sir. It's visible.
So
Perfect.
thank you. So now imagine you're an artist, I'm an artist, or whoever it is, we know drawing, how to draw these things. So I'm drawing a block, a brick, say for example. I'm drawing a brick. Why am I putting these lines? Because brick has a little rough texture. So when we try to draw something, we always try to mimic the kind of texture, that mimic the kind of form or the surface it has. So in order to do that, we have to take these kinds of lines. Sometimes it does not exactly matches the texture that appears into the brick or anything like that. But what happens, it actually gives you a feel of a rough surface. So that feel of rough surface is very much required for even our drawing, because when you animate or try to do something, you always have some kind of surface to deal with. Am I right or wrong? Surfaces are very important. So I'm taking my time and I'm trying to draw the break. That's a brick, right? Roughly that's a brick. Okay, so you can construct house using this brick. But the problem is, or the issue is, I have drawn this one particular thing, and now I give it to you, this drawing. Imagine I gave this to you and I told you, make me a great brick so that I can create no, or give me 5,000 bricks so that I can build up a building here. What would you do? Anybody give an idea? Don't think by the market methods of creating bricks and all those sort of things. Just imagine, put yourself as a layman, and I have given you one design of this brick, and I've told you to give me 5,000 brick. What would be your first job, first work when you start creating 5,000 bricks? Anybody? Okay, so it feels like there is a lot of confusions. Okay, so let me try to help. When you get this drawing or design, you would take it to another designer who will create a kind of a box of the frame. We'll create a box of frames for you. So this is a box or frame. Okay, and you have some amount of clay around that. Once you have this frame, what would you do? You put this clay into that, pat it well, make it flat, and then what would you do? You will just reverse it and you'll take the frame out. So your mud brick will come out. If you use the ordinary clay or mud to create a brick. Bricks can be created by using the what do you call that, um, cements too. Okay, so instead of this you can use cement to whatever medium it is. You can just pat it on, you can just fill it up and fully cover it up, and then what do? You just Somebody has writing. Somebody is writing on the chat. I do not know. For some reason, the chat box is not appearing here. Okay. Yeah. So frame is required. So we make a frame and then we put the medium into it and we then flip it and we take out the frame, so we get the brick over there. All right. Simple process. Fine. Now I gave you this basic design, and just you think that your framer does not know what is the exact size of this thing. Now the problem arises. He would ask you, when you go with this drawing, bricks drawing, he would say it looks like a block, but it also shows that this length or this length, okay, is not equal to this length. Say for example, if I say it is AB and it is CD, he will simply mathematically say like AB is not equal to CD, because it looks like that. Yes or no? You take a measurement, you take a scale and you see, try to see this. I have a scale here. I can just rotate it and try to measure this point. That is the size of this point. If I take it to the back, there is a huge difference, almost half, according to this, right? So there is nothing wrong in it. I have drawn this brick. It looks like a brick. Okay. If I had to take it to a framer, the framer would make me a frame which, if I try to see from the top, that would look something like this. Got it? So the framer would make like this. Why? Because AB is bigger than CD. That is the basic thing he finds out, and he will do with the same process will be followed for each and every of these corners or lines you see there. Why? Because the framer is actually trying to follow your drawing. Okay, and does that mean that this drawing is actually wrong? I made a wrong drawing? Can somebody say yes or no? Or it does not? Does it looks like a brick? Anybody give me answer, yes or no? If you feel like no, I've made a wrong drawing, you tell me I made a wrong drawing. Does that mean I have made a wrong drawing? The answer to that question is of course not. Of course not, because bricks look like this. You make a building, we can create a background and we can create whatever, on this principle only. Because these are the principle given by the perspective. You have these lines should meet somewhere, so they should go like this, they should go like this. So you are exact. There is no question of saying or making a wrong drawing here. The perspective is like that only. But when you try to transform it to a technological world, this building is a very basic and very ancient technology that human has developed. Okay, so using this they have built a house. So we grow and Homo sapiens, we became Homo sapiens, and after that, actually Homo sapiens did these kinds of things, and after that we grow, very modern people like we people are today. So it's a very basic engineering that they did. The problem is, if you follow exact drawing process, it would come out something like this, which cannot be used for making a strong building for sure. If you try to make a strong building using this, it would never happen. It would never stand still, because it is an imbalanced structure. Okay, so two things are arising. The first thing is that things we see Okay, things we see, whatever we see around us, they have one certain kind of perspective. Has what perspective? Has perspective. Okay, so they have perspective, right? And if you're writing the if somebody wants to communicate, I would just request, uh, turn on your mic and speak out the mic, because while I'm talking, I could not really go back and see the chat box again and again. That is disturbing for me actually. So please feel free to unmute yourself and say anything. And there is nothing right or wrong. Even I'm trying to be a wrong in many places. You see, I draw something wrong. That creates a very wrong, engineering structure. So don't worry about it. I would just request that feel free to communicate. Okay. So what we can see, whatever we see, we has a kind of perspective. And do you know why this perspective arises? The reason is that bend in our eyes. So our eye has some kind of bending, be it in terms of our, the lens that eye has, or the be it in terms of the retina. Retina is also not a flat curtain. Retina is also a bent kind of fold there. Okay. So this bending creates, converging effects with the distance. If the distance increases, whole thing becomes convergent. And in case of the camera, you know we are actually replicating to our eyes too. If you see the lenses of the camera, they look pretty much like our eyes lens. So actually we are trying to replicate it, although in terms of the camera, what happens, we do not have a bent kind of film or the sensor behind it. It has a flat sensor, but it does not happen. So anyways, that's not a point. The thing is, there are certain forms that eye introduces, and because of that, the whole thing diminishes, okay, as the distance of the thing increases. Okay, so that creates a perspective. This is what we call the visual perspective. When we have this visual perspective, you know everything diminishes. So if we just draw exactly the visual perspective, it could look fantastic. Imagine a fantastic painting in front of your eyes. You could imagine whatever, a fantastic photograph in front of our eyes, where you see the visual perspectives, and they look really phenomenal. But when this visual perspective is directly employed to the technological world, it does not work. Okay. So the visual perspective has some kind of error that has to be rectified. Always remember this. This visual perspective has some particular kind of error that has to be rectified. Okay. So what do we need to do in this case? The second step is to rectify All right, so visual perspective introduces a error that has to be rectified. If we rectify this thing, what happens? The third step becomes confirmed. What is this? This step is eligible for, what do we call that? The engineering world. Okay, so that becomes eligible for engineering world. That means what? You can create things. Now you can design things. Now the question is, how do we rectify this? How do we rectify this? How do we do this? That's what the question is. Okay. So this basic thing actually comes from, this answer has been given by a few basic things, few things that we have already studied. That is called geometry. So what geometry introduces? Geometry introduces a kind of grid system. Okay, so we have such kind of grid. This is geometry, right? These are the grid systems that we often use, and we call them what? Can somebody tell me what is it called? In nines and tens we have used it like whatever. What is it called? Anybody? Anybody? Okay, this is called a graph. Okay, we had graph paper, we used to draw you know, bar diagrams or whatever different type of diagrams, and from there we used to create our, you know, there used to be a huge marks question, 5 marks or something like that. So we had these bar systems there. Okay, this is a geometry. Okay, using this geometry we can create the same thing, the brick itself. Okay, so that we can create a world that is in accordance to the engineering world. Okay, so what it says, the basic problem was, the solution to this thing actually comes from the basic problem. Here there was a diminution. Okay, like AB is not equal to CD. Now if you have to create a right frame, what would you like to do? You would like to do AB equal to CD. Am I clear? So if you do this AB equal to CD, then your brick structure would be something like this. The same brick structure would become something like this. Right? So there is no diminution. This is A, this is B, C, this is D. Okay? So here in this case, if I draw this, what I can say about this thing, you know, there are few basic statements that we can write, like AB equal to CD, and then similarly AC equal to BD. Now this looks like mathematics. We are doing mathematics here in case of you know, designing structure, lecture or something like that. Of course not. But mathematics and sciences are very deeply involved into it. Okay, whenever you're trying to do a good design, the mathematics and sciences automatically comes to play, because design do not exist without science. Okay, so let us come back to the point first. Now again, we will follow the similar method. You know, whatever the size of this thing will be followed by this area also. The size of this and this has to be same. So we have this. Similarly, this one is also the same. Okay. So A, B, C, D, E, F, G, you can say E, F, and G. So here from we can say, like, you know, A, E equal to B, F equal to D, G. So if you do that and you take it to the frame maker, he would do something which will have, you know, this one. If you do something, you know, make a frame, which if you look from the top, you will find this is something like this. So your problem, which was arising over here, is being now resolved. Now you can use it to create a brick. Am I clear? So what is actually we can see? We can see the whole, you know, science of vision is interacting the existing science that can be applied, and introduces a phenomena of correction. You will have to correct certain areas, and if you do correct certain areas, it is easier, it becomes easier and more correct in terms of replicating the things. Okay, So we replicate the things using this basic method. Okay. So when we create such kind of things, we follow basic rules. How many of you know about, the angles that has been used into the isometric drawings? If anybody knows about it, please tell. Okay. So general cases, the basic angle we take is 30°. All right. So you can just, in this direction, if you are taking 30°, we can take 30° from here too. So to do that, what do we get here? 30°. Okay. If it is 90°, if it is the right angle here, what is this angle then? What is this angle then? Of course, 90 minus 30, that is 60. All right. Similarly, here also it introduces another 60°. This is also 60°. So what is the total length of this angle? 60 plus 60, it is 120°. Okay. So how many angles we are getting? We are getting, of course, this is 90°. I'm getting, it is there, 90°. These are 90 degrees. Okay. So what we are getting angles of 30°, 60°, 90°, 120°. Okay. So these are the set of angles that are often used into creation of the isometric drawings. How do we create it? We first make a design like this one. A, B, C, D, A, B, C, D. Right? So what do? We have this grid like this one. We have one grid. This is 30, this is 30. So what do? We just measure this AB. So we cut down AB, say for example, AB from here. This is A. And this is B. Okay. And BD. So from B to D. All right. This is D. All right. Similarly, what do? We take a compass. We use, since we general cases we use this particularly for engineering world. So what do we take? We take a compass. Compass are used for cutting arcs and all those sort of things. So we measure this distance AC. So from here we make a cut like this from AC, and from here also again we measure this from D to C. So what do we put? The same measurement, taking the same measurement, we put it on D, and then we cut it somewhere in C. So what happens? We get this one point over here, and this one point we connect it, and we connect this one also. I'm not using compass and anything. We're just using the eye estimation for making you understand what the actual process is. Okay. What is the mother of who invented this kind of thing? That's what I'm trying to explain over here. So if we use this, and we have this length also here, say for example this length, so we can just go down like this, and then we can go down like this, go up like this, so we can just build up the whole brick. So if you follow this, what you are getting an isometric structure. This is called the isometric structure or isometric drawing. This is more reasonable. This is more exact in terms of creating these, complicated forms. Now I'm talking about a very basic one. It's a brick, so it's a very basic form, right? Using this, we can create the whole world around us. Okay, so brick is a very basic structure that we even drawing people who are actually drawing fantastic world around you, people who has created paint, the animations like Lion King, they are masters of doing these kind of things. You know, uh, so this is the exact measurement you have over here. So if you take it to a designer, so he will just curve it out in the exact way, and you will get the exact kind of brick that you want. Okay, so this is a very basic structure, and that is the process how we create the isometric world. Okay, so instead of this, if you want to create more complicated structures, like say for example a pentagon. Pentagon is much more complicated than that of this, right? Yes or no? It's a pentagon, right? So if we just create this, what we'll do, we will do the same kind of thing. We will just drop this one, and then here also we'll drop this one, and then they have some other, this one also. From here we will cut it here and here and here, like that only we will create it. Okay. uh, of course we are not doing engineering, so we are not getting into that deep, but a very basic idea is required before we jump into this, world of why this isometric drawing and how this whole thing is. Say for example, you will see a good illustration. A good illustration can exist in two ways: the very normal illustration that you often see in the books and magazines, and then there is another illustration that is nowadays used in all over the web, that is called isometric drawing. Google often uses these isometric drawings to show many things, and many other website also introduces the isometric drawing in many different ways. Okay, so that is very much important to know. So anyways, engineering is our not concern, but this is the basic theory depending on which the whole world of isometric drawing has been created. Now, if we just try to, in a nutshell, before just we try to see some example, I would like to put this thing in a nutshell, So what we see, there is a perspective transformation, right? Perspective transformation. Okay, so you have a perspective transformation that transforms your visual perspective to an applied world of engineering, to an applied okay. So that's how the whole thing works. Okay, so that is why you might have seen those the topics and the agendas that I have tried to design, in this particular way. So that is the requirement. Hope you guys can now understand what is the requirement of perspective transformation before we just try to design those things, because it is there. Such kind of images, in isometric images, are there all across, the Instagram and all those places. Now if you just try to get this thing, you will now understand how this transformation occurs and how this whole world is actually coming to exist. Okay, now there is a story behind it also. Let us get that story later on. Okay, we will see another example. So I'll share the screen actually. Just confirm me if you can see this one.
Yes, sir.
Okay. So what we have is very basic, the brick kind of structure that we have done into a few minutes ago. So the same thing has been said here. You can see it is somewhere in 30 degree. So if you're starting the angle from here and trying to go there, so what do you see? We see that this is sorry, there is a edit mode actually. So anyways, so what happens if this angle increases, then it goes to 90 degree, then it goes to 150 degree. Then what happens? A flat angle or the straight line actually possesses 180 degree. So if you reduce 180 degree, 150 degree out of 180 degree, you get another 30 degree here. Okay, so this angle and this angle is the same thing that we have. I have said in one way, they are depicting in another way, but the thing is the same. Okay, so following this, some definitions has been given. Now definition varies from person to person. I'm not getting stuck with this definition. Okay, so if we, this is a very basic example. If we just try to move into the next slide, excuse me, syntax this. So the problem is, now you see a complicated structure, more complicated structure. Okay, this structure is a little more complicated. It's not like a brick, but it's a complete assembly of different bricks, you can say. Some might have been taken out, some, this particular area has been, you can consider that one brick has been taken out of it. Okay, or if you just consider this whole lower block, you can consider that it's a whole complete block or complete brick. Okay, so these are the one step complicated design, okay, that is coming out of this one only. Okay, so isometric drawing starts from here. The concept has been taken into more complex world of such kind of structure. Okay, if we just move a little ahead, what we see more complicated structures can be drawn here. Degree, angle, inclination, we can see very nicely here. You see these 17 written areas, that is not vertical, neither horizontal. So we have an inclined surface. You see, inclined surfaces. Okay, now I'm giving you these examples. Try to make out what basic things we can see out of it. We see all lines are parallel to one another, right? So all similar lines, similarly oriented lines are parallel to one another. This is not the case in case of the simple perspective. Okay, the simple visual perspective, in case of the simple visual perspective, all lines converge at one particular point. All lines converge at one particular point. Okay, and that is why we create a simple perspective, that, or the visual perspective. When it comes to engineering, these lines are not converging. Say, for example, if you consider this vertical, it is 16.9, 16.7 centimeter, although the centimeter has not been mentioned. But if you just go ahead straight, okay, just connect it and go ahead, you will find the same 16.7 centimeter, okay, over here too. You will get the 7 centimeter over here. Similarly, if you progress along this line, you will get the same 7 centimeter over here too. So there is no perspective reduction in this case. That is the kind of perspective correction that we have used to create another set of perspective that is useful for engineering. Okay, so the world of this whole isometric drawing has came from the world of engineering. Okay, now there is the story why this engineering drawing is intruding into the world of visual arts, right? If you see a fantastic, I could show you one fine drawing or fine work of Xinjiang. She is a very well-known uh, uh, what do I call that, infographics designer. Okay, her infographics are used by most of the pioneering institutes, pioneering business institutions also. She often designed for the Google and many other she has many other clients, and she speaks for the Adobe Creative Cloud also. Okay, she has a few sessions in Adobe Creative Cloud. So if you wish to see her work, you can just go there and you can just consult her works and you can see her works. Now I can see it's a fantastic, beautifully created painting. Or just a minute, let me open it up. I'm directly opening it up from Behance itself. Okay, you see this, these are the blocks. Okay, you have different colors here and they have been kept over one another. But what are these blocks? There is no perspective reduction, either of them. You see, the same method has been used. If you see this, this particular line, this is near 30 degrees. This is also the same thing. It follows the same thing, and this whole thing has been, and this, you know, this particular subject of um, isometric drawing is extensively used into the creation of um, infographics. Okay, so that is what it is. You see, some basic structures has been created, and over these basic structures, another a lot of things are happening here. If you just try to look at it, just look at it. There's a whole lot of story here. Okay, you see parks, people are playing there, children are playing there, some people are at the kitchen, some people are talking, some people are walking. Okay, some people are reading books. Okay, there are trees and plants and all those sort of things. So what is actually happening? She is a visual artist, she is not an engineer, but what she is doing is actually trying to create a world which follows the principle of isometric world. Okay, you see these characters here. There is no perspective reduction too. Over here or here, distances are there between them, but there is no perspective reduction. Okay, so that's one kind of an example that we can really see. And let us go back to this. Now, the story behind it is that you have one world around you, and you're trying to replicate it in terms of the isometric world. Now, question is, why is it so? Can anybody tell me? Okay, if nobody is telling, then I'll have to tell. So, what is actually happening? See, in our world today, there are a lot of engineering equipments around us. Okay, and engineering equipments means you have engineering usage also. Okay, so the world depicting for the engineering equipments has to be changed accordingly. Okay, so if we change this world accordingly, what we'll find, we will find that a more applicable drawing or design method for this highly technological world becomes the isometric drawing itself. If you look at the isometric drawing, this isometric drawing actually depicts the world, the modern technological world, in more effective, much more effective way than that of the traditional designing methods. So that is the reason we have taken this world around us, of this isometric drawings, and formed it into, or transformed it into, a world which is more of the isometric designs. Okay, so here you can see another engineering, a drawing of a camera. Of course, this is a very basic one. More complicated designs are there also. So the similar thing, that was a product. The camera was a product itself. Okay, if we just take it forward, we see the architectural products. Okay, we see the architectural products like this. So of course this is an interior, and it is also very much architectural in nature. So it shows how to this locate these things. If we just go back to Xinjiang's work of the interiors, particularly if you can find some interiors over here, say for example in this particular drawing or this particular illustration, you see the interior worlds has been created, right? All interior worlds has been created. Okay, so how this has been created? Following the similar drawings that we have used over here. You see the methods, there is no reduction in the perspective. Same method has been used, and the world you see around is something like this. These are the interior worlds, okay, for an isometric drawing. Okay, so moving ahead, we can see a little more complicated structure. Now, what is happening? Till this particular area, it was more like an engineering world, right? So there is a lot of design elements into it, engineering design elements, measurements into it. The exact measurements or exact path, exact those kind of thing, exact straight lines, all those sort of things are there. But if we do now, when it comes to the artistic world, the artist would have started, thinking like, okay, it does not look beautiful enough. Okay, we should try to make it more beautiful. Okay, so when we are trying to make it more beautiful, what are the things that we can add up? That question remains. Okay, so when we start thinking about what are the things that we can add up for this particular area so that it looks better, what we can do, we can give such kind of solution. So it is of course not interior, it is an exterior one. uh, Sorry, it is an exterior one, but it shows you the tendency of an artist to imagine things. Okay, if you see here, this is a swimming pool or a pool or whatever you say. Okay, so it's a watery world here, so you can see the waves of the water. Okay, so you can just imagine and how the artist has dissected the water, right? Just like a piece of cake. That's how he or she has, whoever is the artist behind this particular isometric drawing, he has dissected one. At the same time, what he or she is maintaining, is that there should be no perspective deduction here. Okay, so if you just try to measure this length, that becomes equal to this and equal to this also. So if you see, the size of this block over here is equal to the size of this block over here. So even if the distance increases between the two similar kind of thing, there is no reduction into the space. So what he or she is doing, the artist behind this is doing, she is making it, she's imposing some texture into it. Okay, is imposing some other basic element, or visual basic elements into it without any perspective reduction. Okay, so this is how the whole thing is becoming more concrete in terms of the isometric drawing. Okay, so we can take another reference of this kind of thing. Now we are just moving a little more ahead. Initially it was just an engineering drawing, a very basic block to a very basic structure of engineering equipment, highly technological equipment, and then we have applied it into an architecture. Then we have moved into another architecture, representation of architecture with more of details. Okay, with more of details, more interesting, so that it looks more interesting. Okay, to increase this, when the software came to existence, now the difference between this and this is that this is hand drawn. Okay, this particular black and white drawing is hand drawn. Okay, whereas if you just go to the next, this is an illustrator work or any other software. I do not know which software. Probably the illustrator would do such kind of work quite efficiently. So the illustrator is being used to create such kind of works in most of the cases I've told you. Like, so they are using this kind of things, and you see they are even replicating the trees, the very organic shape, very vague shapes of the leaves that are coming out of the branches. That has been transformed into these blocks over here. These are leaves, actually leaves of the bunch of leaves of a large tree. Okay, that has been replicated in terms of a rectangular blocks, which colors like this. What this? That green. Okay, so and it also replicates the sunlight also. You see, some area we have the lightest most green, and then you have the mid tone, and then we have the darker tone also. The similar thing happens for the buildings over here too. Okay, so what do we have in the roof? In the roof, you see the roof section, the front one is having the most lightest area, so that means that sunlight is actually falling on that particular area. And the other surfaces has the mid-tones, like the surface is just around this, has the mid-tones, and the surfaces which falls in the back has the darkest tone. Okay, that's how the shadow effect and the blocks, dimension has been created into this uh, isometric drawings. Now, just like this thing, you see the roads are also not changing much. These things are the basic thing that I'm completely repeating again and again is that you would have to have the similar kind of, the separations between any two lines. No two parallel lines should join nowhere. Okay. So if this happens, what happens? The whole world becomes very isometric world. That is one key concept when you start to design the isometric world around you. Okay. Similarly, if you see over here, this is another more complicated structure and very interesting too. You see some trees have been replicated with the basic geometric shapes, and of course these buildings are of the geometric shapes too. Some, the water has been dissected as if it is it's a piece of cake, or just like that. The whole thing has carries that particular concept. If we just go ahead, what we see is a more complicated one. Now you see it's a cartoony world around. They've used the same isometric drawing, isometric design skills, and introducing the similar kind of character wherein you can see these characters are not reducing in size either. Okay, so the character who is standing in the front is having a size which has been carried by this character also, so there is no perspective reduction in terms of the characters also. And other equipments of the machineries, whatever you see, this clearly shows that there is no reduction, perspective reduction. Okay, so what we see after all, and this is another example of an interior one and a more complicated one. So there is one more story. This is the first set of story that we were discussing, how this thing has been transformed. A very basic engineering drawing has been transformed to a world of isometric drawings where we see different colors, where we see such kind of construction. This is a very basic example, the one you can see on your screen. Okay, so the very basic structures we can see very nicely. They're all very much geometry, but at the same time they are intruding into our spaces. Okay, now if I say talk about the geometry, basic geometry, or any kind of provings and all those sort of things, 90% of you will go home. The reason is that you don't like geometry much. Okay, so why is it so? Because it's a very alien world. You don't like mathematics or those kind of things. That happens, obviously. But you see, those unknown things that we don't like to see around us is actually trying to intrude into this particular area in the form of isometric drawing. Okay, so you understand these things. First, that is, color selection is not a very huge process. You can select whatever color you like. Okay, so two things exist when you do this thing. The first is your design skills. That design skills talks about how you would have to design the overall structure. So once you create the overall structure, you can get into the next level of your design, that is your the coloring method. So I'm just keeping the coloring method apart. That depends on the different artists. Some people might like rich colors, more saturated colors, more dark tones. Some people might like very light colors, very smooth colors. Okay, and very light tones. So that depends on the person to person. But what does not differ is that the design skills, because that has to be the same for both of the people. Okay, so here we see such kind of things that the geometry has clearly introduced into our space. Now, if we just move ahead, complicated structure, again the geometry has been introduced here nicely. Okay, and you see here they have not only okay, just let me put it in this way. I just throw this question to you, what you actually find interesting over here. Now I have been talking for a long time, so if somebody tries to tell me, whatever he or she sees over here, I'll be pleased. Just try to give an analysis. I have been analyzing this thing from a long. So try to give me an analysis, whatever you have learned, from this particular talk? Depending on that, give me an analysis, whatever it is, whatever comes to your mind. Anybody? Do you see any, let me put it in this way, do you see any fun element over here? Any fun element? Okay, it seems nobody finds a fun element over here. So anyways, so if you, the whole thing is like, the concept of isometric world has been carried out over here, obviously. But it really breaks the boundary of geometry and equality and all those sort of things. You see, these meters are placed in such a way that gives this particular machine a character. Am I clear? So if you introduce a kind of a character over here, what happens? This becomes more lively. Okay, if you compare it to some just raw machine, it does not looks like very interesting to you. But when you put such kind of things over here, you see 2 meters are there, and kind of it fits like this one. This conveyor belt is looking like a tongue coming out of his mouth. So it gives a complete whole character. Now this is the artistry behind it. Always remember, this is the artistry behind it, and that engineering thing has been transformed into the artistic world. This is very much important when you are trying to create an interesting uh, infographics or using your isometric drawing skills. Am I clear? So this is a very funny one, and you can see the characters are also very funny. If we just move ahead, we see a more complicated structure which definitely depicts an airport construction where the flights are there, where the waiting rooms, lounges are there, where scanning of different luggage is happening. People are moving in through the metal detectors. You have different sitting areas, different baggage delivery systems, all of those sort of things. Okay, now this is obviously again isometric, but the problem is, it's not just isometric because it has a story to tell, it has an experience to share. Okay, now when you get into an airport or something like that, whatever you encounter, okay, whatever comes under your experiences has been depicted nicely over here. Okay, you come across a place where people are sitting, you come across a place where the airliners are sitting in a row, they are attending you, and you come across the metal detectors, your bags have been scanned. There was another person here, you can see another person, oh sorry, not this one. If we just zoom it in, what we can see the level of details. Okay, each section describes one particular story. A person sits and watches this carefully, whatever is going on. Okay, so that's what exactly actually makes your uh, you know infographics more effective, more efficient. So if you just do not put this one up, even if you just omit it, imagine that you have omitted this particular thing. This person who is actually checking the packages. Okay, and you see this this person is moving across the metal detector. Without this one person, what would happen? It won't be that interesting. It does not tell you the story why this thing. is there? Why this such kind of security systems are such a complicated security systems are there? There is a solid reason behind it, and that solid reason behind is depicted. That security reason has been depicted by the native attendants of this particular person. They are actually very seriously looking at the X-ray scanner. Okay. So similarly, the baggage delivery system, how the baggage has been delivered. Okay, and uh, that's how the sorry, just a minute. That's how these baggage systems have been delivered into the airport or the flights. Okay, while and people are actually waiting in the lounge. Okay, so their baggage systems is very nicely placed. When you get into the airport, your baggage has been taken. Then what you do, you take your boarding pass and you wait in the lounge there. Okay, to be called up for the flight. Okay, and the moment you are actually sitting in the lounge, you are chatting with somebody, with your friend next to you. Okay, and sometimes you are very excited. You see nicely been designed. This person, this old man here, or he's spreading his hands like this, as if he's telling, like, oh, there is a huge amount of delay and all that, I have to do this, do that, a lot of things, he's like maybe sharing his very bitter experiences to the next person. So everywhere you see a very nice, storytelling happening all across, isn't it? And at the same time, your baggages, whatever you have left up, is being loaded up into this truck, and that truck actually delivers all these things to the flight itself. Okay, so that is how the whole thing is. Overall construction is like this. Although if you just look at it, it's a very good infographics, but in terms of the proportions and all those sort of things, there are certain areas that one can work more radically into this particular area. Okay, so that's how the whole thing is. So far, any questions? If you have any questions, you ask me. Okay, so this is the basic collections of the whole set of collections that we have over here. Okay, somebody's writing the chat box. The chat box is not appearing. Okay. Anyways, that's a different thing. So we go back to see what a more complicated or more effective, designs could be, in terms of storytelling of that has been associated to, and infographics that has been associated to, isometric world of isometric drawings. I would just request to head on to Behance and see her works, Xinjiang. Okay. We try to look at this one also. Hope my screen is visible to you. Now there is a huge concept of smart cities. Okay, when you look around, many people are, talking about the smart cities. Okay, we were also supposed to be having thousands of, I don't know, thousand or whatever exact number, but we used to have supposed to be having a number of smart cities. Unfortunately, none of the cities are smart enough. So, anyways, so here is a concept that she has designed of the smart cities. And you see there is it's a very complicated structure at the same time, all isometric. but a complicated structure. Okay. Now, why am I bringing this thing there? I do not know whether how many people are interestedly, very dedicatedly listening to this talk. If someone is dedicatedly listening to this talk, then I could have come across the thousands of questions by now, for sure. Okay. So the whole thing is why these smart cities are, what special things is about. The basic special thing in a smart city is that you have very nicely well built up, facility structure there. That's first thing, the facility. Okay. Very nice communication. Number two. Number three is you have very nice, engineering, or the not the engineering, the energy engineering management, you can say. How the energy has been managed into these cities. Okay. So when you are trying to manage the energies, you would try to introduce, the bio-friendly energies. Okay. That produces less of emissions. So there has to be a lot of electric vehicles around you, electric, support systems. Like here we can see a set of, what do we call this? Solar panels. Okay, that creates one particular section. It means one particular section of solar, solar section where the solar energies has been generated. Here also we can see the complete, structure where the charging station, electric charging cars have been parked. Okay, so you are actually parking your car over here and you are charging your car. At the same time, when you are going out when you are not driving, you are out going out for something. Maybe you are marketing or anywhere you're meeting a friend or whatever. That time you can charge your vehicles. Okay, so just moving ahead, you know there are multiple areas where the solar energies has been applied. Here also we can see at the rooftop of these buildings, the solar energies uh, has been employed. The solar cells has been employed to create the energies, and that energy has been also used for the communication purpose. So we see these Wi-Fi signals over here. Okay, so the Wi-Fi signals are there, and you see the whole bus system and all those sort of things looks very clean and neat and neatly designed. Okay, so efficient signaling systems. Okay, a reasonable number of trees here and there. Okay, so that's a whole structure. That's a whole construction of this. It's not happening anyway. So okay, go ahead. So in this section also you see a lot of the similar kind of methods and similar kind of structures you see over here, and accessible hospitals, and so that's how the whole thing is. What she's trying to tell is that whole thing has been you know stitched together in terms of one particular item. Okay, so what is that particular item is the solar energy panels and the communication Wi-Fi signals. So you see a kind of a chain into this. In each sector, in each area, you have these solar energy systems and Wi-Fi signals and all those sort of things. So what is actually happening? It has many different levels here and there, and many other. Some windmills are there also. Okay, so that the energy can be generated. So energy connections are all over these constructions. Okay, and that has been used into this particular the structure of this design itself. Okay, so that's how the whole infographic is. And infographic is one place where we use our isometric drawing skills quite and often. Okay, that is why I'm bringing this uh, infographics into the this particular webinar, because when you take it to the engineering drawings are one kind of thing. When you try to take it to the world of design, that happens to be the infographics. Now, infographics has existed because of the communication, the engineering communication, or the technical communication to the mass or the people. Okay, so what has happened? You see some, booklets that comes, or the usual manuals that comes with the mobiles or any other electronic devices. If you go for the high-end speakers or high-end, amplifiers and all those sort of things, you would often come across those kind of thing. The booklets where everything has been designed, and if you see the images inside, they all are actually isometric in nature, because they have been derived from the engineering drawings. Okay, and now when you have to communicate this particular to the mass, you will have to add that drop of honey into it, so that they can, what is that honey, what do you mean by that honey? I'm talking about the visual honey. Okay, the visual sweetness, so that the people can absorb it nicely. Okay, if the people can absorb it nicely, what happens? This becomes more evident, more exciting to the people. More people get caught by the images. So if we just, I do not know how many of you like this particular images. I like it very nicely. It really is a fantastic image to me. The way she has done it, the way she has, separated these things, and everything is, you see, details, this drainage systems, all these sort of things, how the drainage system is going, at and now whenever the drainage system is there, always remember there are some, the natural hazards are, involved into it, because the drainage system often carry a lot of toxins into it. Okay, so there has to be a kind of a, what do I say, the scientific data that deals with the, the outcomes of the drainage systems. So if you do that, you just see, look at this area. She has nicely put this pie chart over here, and these kind of charts are quite and often used while, you are talking about these toxic things, or the other things like that, similar kind of things. So she has just put exclamatory mark, and underneath that she has connected to a statement that might say about how, these drainage systems are safe. Okay, so these are the little details that has to be there when you work, I mean, with the isometric things into your visual dimensions. Okay, so some other different sections that has been, this is the CCTV camera, has been also been derived over here. And these lights actually talks about the signaling system that had often been used. Okay, kitchen, kind of, again an interior, and a very nice interior. Okay, how you are actually working with this one, I could not see. There's another one very nicely done, infographics for many other things. It's a park, or the environment kind of thing. See the DNA structure and all those sort of things. When you cut it, how does it look, and all those sort of things. These are all very engineering. So that has to be bought. The whole idea is like, when you are creating one infographics using the isometric drawings, you will have to tell a story behind it or connected to it. The same kind of thing has been done here. So you have one DNA sequence over here, but you see also the other, the researchers working around this one. Somebody cuts it, and somebody finds it, somebody tests it, okay, and somebody makes other preparations too. Somebody is, having some other works, other set of works also, and other experimental things also. So those things have been, brought together over here under this particular area. So there are a lot more actually. And you see, even in this area, all of these things are being connected. Nobody is not, is actually free from one another. That's not so. Okay, so what is actually happening? You have one level that has been connected to this one level through this particular pipeline. So there is a kind of connection. So if you start watching from one particular area, you can move to another next section of it this, and you can take down the staircase and go down to this one level, so and you can go here also. So what it actually does, these things actually allows you to move across the frames, move across different areas that you have. Okay, and that's how the whole thing is. You can see this, how the whole of our lifestyle is being very much nicely been reflected in every dimensions in this particular work. Yeah. The online marketing, we can clearly see this, and a couch has been nicely been kept in between, so that whoever, if somebody thinks like, where you can do the online marketing, of course, sitting home on a couch, you can take out your mobile, you can choose for any particular thing, you can pay it off, the people will come and deliver your things at your home. So that is one analysis of one great artist. So I would just request, go to this page and see all of our works. Okay, so if you see all of our works, you would definitely get a nice experience, how this isometric world can really create wonder when we mix it to different life experiences. So these are life experiences. Okay, if we let me try to see this, if I can find another one. Hmm. See, she is using a kind of a three-dimensional structure over here, where you can see or thing like, you can really move it. Okay, so that movement is very much important over here. Few minutes ago, in the beginning of this session, I was discussing about one brick, and if you just, what happens if one area was larger than another area, according to our basic perspective. So what is actually happening? You can't move it. If you move, the whole thing becomes reverse, right? So, but that was due to our visual errors that we had in terms of the perspective. But if we have to deal with a very engineering kind of thing, if we move it, it should still be the same. Okay, it should not become where something is small, something is larger, or something like that. It should not be so. So here, what you can see, she has used that concept of movement. Okay. So why am I saying this movement? You see this Eiffel Tower has been raised onto the right side of this pyramid, and it has a three-dimensional construction all over. Three-dimensional construction. This surface, she's using this surface for different, different elements like, Big Ben, and then you have a lighthouse over here, and then you have, what do you call this, the Eiffel Tower over here. Right opposite to that, you can see the Statue of Liberty. Okay, and then you have the product delivery system over here. And when it comes to the watery surfaces, you could see a canal-like structure which also have a three-dimensional effect. So you can just move it. What is actually happening? She's stretching her, imaginations. Okay, water does not look like this, but she has taken it in the form of a rectangular construction, so that you can say that there is, if you'd like to do this kind of thing with the water, you would have to have a very nice engineering to it. So she is trying to incorporate the engineering things into the vision also, whereas she's trying to liberate her visual freedom also at the same time. So that's what really makes these images very interesting to many of the people around. So you see, you can, if you just tilt your head, this becomes the straight one, and if you just can flip it completely, this becomes the straight one. This becomes the straight one, and rest of the things, what is happening is actually using the three-dimensional form of it. Okay, so these are the applied areas where we, and this is how we apply this particular thing, which is called the isometric drawings, isometric designs. Of course, the effective software behind this is Adobe Illustrator. She uses Adobe After Effects too. but Illustrator can create such kind of works very nicely, no issues with that. Similar kind of thing. So there's a lot of explanation. If you have any questions, please have a luxury of asking questions. If anybody has any questions, please feel free to ask. Nobody has a question to ask? Okay, it seems that nobody has any question. Uh, so hope that really helps you out when you design something. You know, how would you design? How would you put things together so that it could become a very nice infographics at the end of the day? Because whenever you are creating, always remember, whenever you are creating isometric drawing, the end product of the isometric drawing or the end usage of the isometric drawing is actually into the area of infographics. Okay, so you have to create the infographics. That is what exactly we use for that. Be it in terms of a technical writing stuff or be it in terms of anything else, we use that particularly. Okay, isometric designs. Uh, uh, and hope my lecture, whatever we have discussed today, will help you a lot in terms of designing the isometric worlds around you and create better infographics in future. So with that all, I would like to wind up the session over here, as there is no questions, no more questions coming out from you. We wait for 5 more minutes if somebody finds any questions to be asked or any doubts or have any other technical issues for which sometimes some people cannot, communicate. And after that, we will wind up the session. We have Rajat with us. We can see. Rajat, are you there? Okay, hope that will help you a lot in future. With that, thank you very much.